In the beginning, there was no code. No lines of syntax, no compilers, no frameworks. Only raw machines, massive humming beasts of metal and vacuum tubes, waiting for instructions. Imagine standing in front of one of these early giants, like ENIAC in the 1940s. To make it do something as simple as add two numbers, you had to rewire panels, flip switches, and configure thousands of settings. Programming wasn't words. It wasn't symbols. It was physical labor, closer to engineering than to the creative act we now call coding. But then, something happened. A revolution, almost invisible at first. Someone, somewhere, looked at the blinking lights of those early computers and thought, there must be a better way. We don't have to speak the language of the machine. The machine can learn to understand us. That moment was the birth of the first programming language. But who designed it? Who dared to take the first step in teaching humans to speak to machines in something more than raw ones and zeros? This is the story of the first programming language, and the people bold enough to invent it. When we ask, who designed the first programming language? The answer is not as simple as naming one person or one date. The history is tangled, layered, and filled with pioneers who each built pieces of the foundation. Some would point to Ada Lovelace in the 1840s, the visionary mathematician who wrote the first algorithm intended for Charles Babbage's analytical engine. Her work was never executed on a real machine, but her notes described instructions in a way that looks strikingly like code. By that definition, Lovelace may be the first programmer, and her language the first of its kind. Others argue that the true first programming language emerged a century later, in the mid-20th century, when computers finally became real. Assembly language, short mnemonics that represented machine instructions, appeared in the late 1940s. Instead of manually toggling switches, programmers could now write ADD-AB instead of raw binary. It was closer to human thinking, but still intimately tied to the hardware. Then came the giant leap, a language not written for one specific machine, but abstract enough to run on different systems. This was Fortran, created in the 1950s by John Backus and his team at IBM. Fortran was not just instructions, it was mathematics expressed in code. It was a bridge from human thought to machine execution. Fortran is often considered the first true programming language. So, who designed the first programming language? Ada Lovelace. The vision. Assembly language pioneers. The first step. John Backus, the architect of abstraction. Each of them, in their own way, laid down the first lines of code. To understand why this was so revolutionary, imagine an alternate reality where no one ever created a programming language. In that world, computers remain locked behind the barrier of machine code. Programming would be a job for only the most specialized engineers, each tied to the quirks of a single machine. Every new computer model would require relearning how to program it from scratch. There would be no portability, no sharing of code, no global collaboration. The personal computer revolution of the 1980s, impossible. The web, unthinkable. Open source software, dead on arrival. Without programming languages, the digital world we know today simply could not exist. The creation of the first programming language was not just a technical milestone. It was a declaration that machines could serve humanity, not the other way around. Ada Lovelace in the 1840s translated an Italian paper on Charles Babbage's theoretical analytical engine. But she didn't stop there. She added her own notes, 3 times longer than the original text, describing how the machine could calculate Bernoulli numbers through a series of instructions. This was more than math. It was structured step-by-step logic, a program. Though the engine was never built in her lifetime, Lovelace foresaw a world where machines could manipulate not just numbers, but symbols, music, and even art. Her language was visionary, even if it never ran. Fast forward a century. The first electronic computers, ENIAC, EDVAC, Manchester Mark Warburton, were programmed by rewiring or by feeding punched cards full of binary instructions. This was slow, error-prone, and brutally difficult. Engineers soon began using symbolic representations, words like load or store, to stand in for binary codes. This was the birth of assembly language. It wasn't portable. Each computer had its own dialect, but for the first time, humans could write code in something resembling words. Then, in 1957, IBM introduced Fortran, formula translation. John Backus, frustrated with the drudgery of assembly programming, led a team to create something radical. Fortran let scientists write mathematical formulas almost as they appeared on paper: X, A, B plus C. The compiler, the software that translated Fortran into machine code, was itself a triumph. It proved that machines could be programmed to understand us, to do the hard work of conversion, freeing humans to think in higher concepts. Fortran became the first widely adopted high-level programming language, and its legacy still echoes in supercomputing today. But let's imagine, what if none of this happened? What if no one had designed the first programming language? Without Ada's vision, perhaps we would never have thought of computers as creative tools. They might have remained calculators, nothing more. Without assembly language, programming might still mean physically rewiring hardware. Each program would take weeks or months to prepare. Without Fortran, scientists in the 1950s would have been shackled by the impossibility of writing complex programs. Weather prediction, space exploration, nuclear simulations, all of it would have been delayed by decades. The chain reaction is clear. No languages, slower research, slower technological growth, slower growth. No internet in the 90s, no smartphones in the 2000s, no AI today. The world you're living in right now might never have existed. Thankfully, history didn't unfold that way. Ada Lovelace planted the seed of imagination. Assembly gave us the first taste of symbolic code. Fortran opened the door to high-level languages. And from there, a cascade. COBOL for business, Lisp for artificial intelligence, C for systems programming, Java for the web, Python for simplicity, JavaScript for interactivity. Each new language built on the last, layering abstraction upon abstraction, until coding became something millions of people could do. Today, you can sit at a laptop, open a text editor, and with a few lines of Python command a machine billions of times more powerful than ENIAC. That miracle is only possible because someone, long ago, asked the question, what if the machine could learn our language? So who designed the first programming language? It was not one person. It was a lineage, a relay race across centuries. Ada Lovelace envisioning, the assembly pioneers implementing, John Backus abstracting, and countless others. Grace Hopper with COBOL, John McCarthy with Lisp, each carrying the torch forward. The lesson for us today is simple. Programming languages are more than tools. They are acts of translation, bridges between human imagination and mechanical precision. Each new language doesn't just make coding easier. It reshapes what is possible. When you learn a language today, whether it's Python, Rust, or Go, you're not just memorizing syntax. You're stepping into a history of human creativity that stretches back nearly 2 centuries. The first programming language was not a single invention. It was a turning point in human history, the moment machines became partners in thought. And so we end with a question. If Ada Lovelace could look into the future and imagine computers writing music and art, what future visions are we blind to today? What if the next great leap is not us teaching machines our language, but machines creating languages of their own?